Okay, so what we're going to have a little look at is Newtonian physics and how that's obeyed in this video game here called Portal, right? Because the basic principles of Newtonian mechanics are followed whenever possible in this. It's quite nice. Now, the first thing we do have to address is that this, the idea is I can create
the enrichment center is committed to the well-being of all participants.
Right?
Cake and group
now,
counseling will be available at the conclusion of the test.
That we
Thank
don't
you for
have,
helping us
obviously
help
this
us
technology to create portals that you can start running through all day, right? Is it something, within the realms of possibilities? Maybe. If we think of people like theoretical physicist Michio Kaku, who you might have seen his book, Hyperspace, I had to hand in a previous video. And I've read some other stuff like Physics of the Impossible. He believes that, one day we'll be able to teleport, maybe things like water molecules to the moon and send those up there. Because actually, currently, something that we can do is we can teleport simple elements from one place to the other. Now, unfortunately, this type of teleportation, what it does result in is it results in the original being destroyed and then it being recreated elsewhere. So that would be a problem here, because if a human stepped through, right, it would have destroyed the original that was back there and just created a new one over there. I personally wouldn't like that, yeah? So in Star Trek, whenever they're teleporting somewhere, Captain Kirk dies and they create a new one of them on the other side, right? Also, we got to think about, elements being pretty easy to, teleport. But think about how many muscles were made up of it, tissues, and then cells, and then, and then atoms within that. It's a bit sketchy to me to try and teleport humans. I don't know if that's something that's going to happen. Anyway, so this technology is beyond our means for now. That's not important, though. What's important is the Newtonian mechanics that are being obeyed. Number one, conservation of mass. When I step through here, mass is conserved, right? And luckily for us, life as well, right? I step through here, all my no mass is lost. That is wonderful. That is excellent. And then that's going to lead us on to something that else is conserved, momentum. Momentum's conserved through portals, yeah? Conservation of momentum. Remember, I wrote a song about it. It's another fundamental law of physics, of classical mechanics. The law states the total of the momentum of the objects in a closed system cannot change as long as there are no external forces acting on the system. So in other words, objects are going to continue to do what they do as long as nothing bothers them. Now this is really vital for the sequences in this video game, right? Because momentum is something that, if we take advantage of, it means that, let's see if I can see this. Look. It means that if we take advantage of it, right, something really small like a bullet or like my body in this game can end up having the same momentum of a, an elephant running in the same direction. Because momentum is a product, a vector quantity that's a product of my velocity and my mass, right? So it's time to kind of exploit this conservation law, right? So, flinging something we can do in this game, since our momentum remains the same through portals, reaching high areas, like, up here, often requires me to gain momentum through other means. So, I've got to place a portal somewhere, so I can place one up here, right? And then I'm going to drop through that portal, right? Woo. So, what I did there is I took advantage of the conservation of momentum, right? I used my free fall. I used the acceleration of free fall by dropping through the air, right? So I go through here, and I drop through the air. As I drop through the air, I accelerate due to gravity, the acceleration of free fall, right? And I gain speed. Yeah, acceleration by definition is at what rate you're gaining velocity, what rate you are gaining speed. So I'm gaining speed, and thus as a consequence of gaining velocity, because velocity is, a proportional to momentum, I gain momentum as well. So if I place a portal where I ended up landing, I'll emerge from the first portal, only to find I've been flown across the obstacles once in the way. And it's possible to do this, and gain more and more momentum and go over bigger and bigger gaps. right? So I had that one blue one up here. I set up my orange one. I fall through it. I accelerate, you know, and I gain momentum. It's not enough to fling me, so I just need to do that twice. I need to just continually gain momentum. Fall through, and as I'm accelerating, take advantage to conserve my momentum again, and whoop, whoop, way, and then off I go flinging, right? So it's basically like I would need a running start to gain more and more velocity, but I'm taking advantage. I'm taking advantage of gravity's acceleration to basically act as my running start. It's pretty neat. There's a bunch of other stuff in this game that does also follow all our classical mechanics. So you could, you know, be playing something like this, and constantly in your head you have to think about, okay, F equals ma, where's this vector going to send me? And you're constantly doing those little things in your head, yeah? Real physical concepts are incorporated into this, yeah? And you've got, and what better way to, you know, kind of have a go at classical mechanics than throwing yourself around like this? It's actually pretty neat and pretty fun. Okay, so hopefully we got a little bit, we got another demonstration of how momentum is conserved. Hopefully that's, you know, bringing our understanding of classical mechanics just further and further where it wants to be. Because as I said, you understand this Newtonian physics, you've just got the building blocks to start doing amazing things. Alright? One more time. Woo!